anything new, different? Oh, I guess I should get that.
All right, so I want to do these next couple together, and then I'll give you some like this. This one looks really complicated, but the main thing I would see up there, what do you think the first thing I would do? Flip them. I love it. So you guys have kind of caught on to my way of doing things. You don't have to do that first, but that's the first thing I do. So both of these want to flip, don't they? They're both to a negative power, so this whole thing would go up, and this whole thing would come down. So I'll end up with, on the top, I'll have 5y to the fourth. It's positive now, because it's done its job, right? On the bottom, I'm going to have
2y to the positive 3.
I like it. So now you can attack, now you can attack each one of those.
Would they cancel out, maybe?
Not yet.
Okay.
So why can't you kill those y's? Because can you divide first, or what was order operations say? Are they like bases?
Oh wait.
Yeah.
No. What do you have 4 of on the top? 5y. What do you have 3 of on the bottom?
2y.
Are the bases the same? No. How are we doing so far? Is that understood? So order operations will always save your ass when you're not sure what to do. Do I divide first, or do I do exponents first? Exponents. I like it. So how do I do this exponent here? Okay, cool. 5 to the 4th. Y to the 4th. Over
Jesus. Oh, that way.
2 cubed. Y cubed. Now what can you do with this?
Combine.
Okay.
The y's
You can
will
subtract.
cancel
Or
out,
subtraction.
Yeah. So how many y's do you have left?
right?
Where?
On top.
On the top. I like it. You go with me? Because 4 minus 3 is 1. Or even better, 3 y's cancel, leaving you with 1 on the top.
Oh, makes sense.
And then all you can really do with the numbers, 5 to the 4th, somebody said 625. What's 2 cubed? 8. Now real quick, can anybody tell me how I know that that's not going to reduce? I don't even try.
Because of the 5 and the 8.
Even better. Because the 5 and the 2. 625 is made of 4 5s. How do I know that? Because I see it right there. That's where it came from, right? 4 5s. 8's made of 3 2s. Do they have anything in common? No, so don't even waste time. You saw what they're made of before you took that step. Don't waste time trying to reduce that. It ain't. One's got 2s, the other's got 5s. Nothing in common, leave them alone. How we doing?
Okay.
Okay. His phone's freaking out. All right. This guy. Now here's the interesting one. What do you think is the last thing I should do on this problem? Which exponent? The very outside one. I love it. Forget that that is there for right now. What's the only thing I could do on the inside?
You want to flip them?
I love it.
Wait, what? Oh, flip it.
So what's still on the outside?
The -2.
It's just sitting there waiting, right? Does that make sense? Because what am I raising to -2? I don't really know. There's stuff I can do on the inside, and what is that stuff I can do inside here?
Yeah,
Flip them. So these, what stays in the same place?
Oh.
The cube. Everything else, these 4 p's, they want to go down.
So it's
These 3 r's, they want to go up. It's trying to be a 3. I like it. Do you guys see that? Don't make it more than that. If it's a negative power, it goes to the other side. That's it. Nothing else I can do inside, right? There's no like bases. So now what 2 things does this tell me to do?
you gotta flip something else.
What do I get when I flip it?
1/2.
Oh. 1
No,
over 2.
come on now, be careful. I'm glad you said that, and I don't feel bad. I'm not raising the 2 to a power, am I?
No.
So I don't make that 1/2. What am I raising to a negative power?
The cube.
All that crap in there, right? R cubed, Q, P4. So what do I get when I flip it?
The original one.
What do I get when I flip it?
2.
Careful, not quite.
Jump.
Flip this. Flip it. P4 over R cubed Q, right?
So if you have a negative exponent after you've done, like, after you've done the first part and flipping the negatives, and if you have negative exponent. flip
So
the
tell me this,
negatives.
why did that P and the R flip? Because they had negative powers on them. Why did I flip the whole damn thing? Because it had a negative power on it.
Okay.
You guys see? So keep them separate. Do the outside power last. Don't even think about it. If it's negative, good for it. Right? When I get the inside done, then I go, oh, the outside's negative. Flip the whole damn thing. What do I still have to do? Square it. I haven't done that yet. I did the negative part. I didn't do the second power part yet, right? And how do I raise all that to the second power? P to the 8, not 16. P to the 8th, R to the 6,
Q.
and Q to the
2.
2nd.
Okay. And that's the final
And
answer.
that's it. I don't.
That's
I
it.
like it.
There's nothing else I can do there. It's that simple. No, it's not simple. Now, obviously, I think the hardest part about these problems is that there are so many different ways to do them. That some of us do half of one way and half of the other way, and those don't go together. You end up with some freaky ass answer. You do part of this and part of that. That doesn't make any sense. You've got to attack the way that makes the most sense. And the way that makes the most sense to me, and the way that I think keeps us from making mistakes, is to flip things with a negative power first. Get that out of the way, so that we don't make a mistake where they're negatives. Some of my colleagues actually disagree with me. They would want to do the negative 2 power first. And if you want to do that, feel free.
Then you're still
Personally, it
gonna
just doesn't make
flip
as
it
much
twice.
sense.
But even if you did the 2 on the outside first, you still have to flip it.
Well, you bring a negative 2 in. The whole negative 2 would go in. I just happen to think that's not the best way to do it. So here, you guys try to do that problem. I'll leave you the hardest problem. Oh, you'll be okay. I shouldn't have to say this, but what would you do last? The negative 3rd power. So focus your attention on the inside. Yeah. You could. You could bring a negative 3 in. Good. Bless you. Yes.
Was it last time you found it?
Let me see.
Because I put this side in there.
Oh, no, but you didn't, you simplify the inside. And it's a negative 3 still. Right. So first simplify the inside. And the last thing you do is that negative 3rd power. That's my suggestion. There are other ways to do that. No, because what are those 2 on? Since it's to a negative power, they want to. Come on, don't. Well, you could think of it that way, but don't those 2 y's want to go down there? Because they're to a negative power. Then how many y's would you have down there? Total. Yeah. There you go. That's the way it normally works. Now from here to here, I'm not sure how that 2 became positive. It was negative 3 and then it was positive. Now if you flip it, it should actually be
I
a
love
positive.
it, yeah. Did you finish it?
Yeah, looks good.
Did you get your final answer?
Here's the better way to look at it. Don't even bring this step in. How many x's would cancel? How many would be left? Where? There you go. Just go straight to that. Don't even bring the negative power in. Yep. So yeah, this is what I'm talking about. So you can bring that in from the very beginning. Cool.
12 y is already good, is there?
12 over. Looks good. Yeah, it's good. Cool.
What about, same thing, whatever's negative?
Yeah, so you brought the negative power. Now be careful, negative 2 times negative 4 is positive.
Yeah.
Same thing with the R. Yeah.
Oh. Oh,
Okay. All right, let's see. So here's the way that I would do this. There's a lot of stuff I could do in here, right? There's like bases, there's negative powers. So I would take these two y's down there. And here's the cool way to look at it. If you get better at this, I'm going to bring two y's down. How many y's are already down there?
4 y.
How many y's are already down there?
Or 2 y.
2.
Sorry.
So if 2 more are coming, there will be 4. So you can see that on that step now, right? How many y's are down there? 4. And what happens with the x's? X squared over x. There's just one x left on the top, right? And there's y squared, y4 on the bottom. Now see, that's why I personally like to simplify the inside first, because now I got less stuff to raise to the outside power.
Wait, so the x's went away.
X squared divided by x. How many x's are left?
None.
1.
1. Okay.
If I have 2 x's over 1, I got 1 left on the top. Cool. What does this tell you to do?
Flip it again.
Flip it,
And then move your paper.
and then cube it. Oops, sorry. Thank you.
And
See,
then
so this
y
tells me to
squared.
flip it. I flipped it, but I still have to cube it.
But now
And what I get when I cube it, y to the
12,
12
x to the third.
over x to the third. I like it.
Oh, yeah.
So I am certainly not saying that you're wrong if you do it a different way. I would never ever say that, especially when the other way is legal. Right? So there's a million different ways to do this, which is one reason why it's hard. Believe it or not, having too many options kind of sucks in math, because then you do part of one way, part of the other way. But as long as you ended up there and you show me your steps, you're fine. Okay. Real quick little thing here. The way I would do this problem here, x to the 4th over x to the 9th. I wouldn't even bring negative powers in. I know the property says, what does the property say to do here?
Add,
Because I
Guys.
didn't get to that.
Oh.
The property says to do what now? Subtract.
Because it's division.
And then have a negative power, you gotta flip it. But here's a better way to look at this. How many x's would cancel? How many would be left?
5.
Where?
On the bottom.
You're done. 1 over x to the 5th. You're done. The property would say 4 minus 9 is negative 5, but what's x to the negative 5th? 1 over x to the 5th. So skip the stupid negative part, right? I don't mean it's stupid, it has no place in math. I'm just saying, why go there if you don't need to? There's a much simpler way to look at it. How many cancel, how many left, where? You're done. Okay. So a little preview of the next section, then we'll head out. Oh. Let's see what kind of reaction I get from this question. How much do you guys know about scientific notation?
I like that.
You like this stuff? I like
did
that.
back in the day.
I like that response. Some of you guys are giving me this.
I had physics last semester.
If you had any science classes, you've probably run into scientific notation, because they're used to represent really large or very, very small things. Right? So, and it's kind of funny. It's sort of like exponents, and it utilizes exponents to write something really large in a much more compact way, because math people are lazy or frugal with their time, whichever way you want to call it. So here's an explanation of why scientific notation works the way it does. And if you don't remember it, if it's been a while, here we go. I'm going to start from the beginning. 4,000. That is 4 times 1,000. Incredibly number. So the whole purpose of scientific notation is to suck all the tens out of something. You probably never heard it put that way, but I like to think of it that way. Scientific notation tries to suck all the tens out of a number. And that would leave me with a number between 0 and 9, like between 1 and 9. So this would be 4 times 1,000. So one place, the one last place where the x means multiplication is with scientific notation. What's a more compact way of writing 1,000? 10 to the third power.
4 times 10 to the third.
Okay, so that's a more compact way. 4,000 is not a very big number. This is obviously just a little example. I wouldn't write, this about takes the same amount of time to write both of those. What about this guy? How do you write that as a fraction?
Negative power.
Now how do you write that as a fraction?
4 over
4 over
1,000.
1,000. Tenths, hundredths, thousandths. What did we just say 1,000 is? Now here's the cool part. Think backwards. If I force that dude up to make it look more like this notation, what has to happen to the power?
It's become negative.
It has become negative, because where does he really want to be? On the bottom. I made him move up, right? So this will become 4 times 10 to the negative 3. Now I'll tell you this, I suck still to this day at left and right.
No.
Yeah, you do like this. So when somebody's giving me directions and I'm in the car and they say turn left, I've got my hands like this, so the one that makes an L is left. I will admit to that because I got too much other shit in my head. I can't keep left and right straight. Just give me a break. So I hated it when they taught this and they talked about move the decimal left and move the decimal right, because depending on which way you go, it changes. Screw that. Here's something that makes much more sense. A positive power makes it big. So if it's big, it's a positive power. If it's a positive power, it's big. And I say big, I mean more than 10. You with me? So positive power means big. So if you like moving the decimal certain places, here you would move it to the right 3 times. And of course, what if how many times you have to move it to go the other way? And you move it left. So you got to remember, in this case it's left, in this case it's right. I hate that. Positive power, big. Negative power, small. Right? So if it's a small number, I know my power is going to be negative. If my power is negative, I know my number is going to be small. I don't have to remember left and right, and they change if, depending on, screw that. Right? So that's me way back when saying, that's nice, teacher. Here's the way I'm going to teach myself how to do this, because I don't know left and right. So here's the kind of problems you're going to get. Can you write this in scientific notation? So if I write psi naught, that's scientific notation. Let me see if we can go from the very simple example to the more difficult example. Where do I want my decimal to end up?
Right after before the 4.
Before the 4, right after the 1, right? Because I want the digit left alive to be a single digit. I don't want to stop here, because then I got a 3-digit number in front of it. 143 still has a couple tens in it, doesn't it? And I'm supposed to be sucking all the freaking tens out. So how many times do I have to move the decimal to get it here? 3, 6, 9, 10. So what is this main number now? 1.43 times 10 to the positive 10. I love it because it was big. Not because I went left or right, because it was big. How are we doing so far?
Makes sense.
All right. And what about, and clearly enough, I'm going to give you this kind of problem.
How many zeros?
Good luck trying to count that.
You want us to try this?
Yes. Same idea, except you're just moving it the other way. Where do you want the decimal to end up?
After one.
After the 1? So you have to move it 1, 2, 3, 4, 5, 6, 7. So it'll be 1.07 times 10 to the
-7.
negative, because it's small, 7, because I moved it 7 times.
How
Yeah.
do you decide where you want the or where you want the decimal to go?
It's not your decision to make. You have to have it stop so it has a single digit in front of it.
Okay.
So if I stop there, as it's 0 doesn't count. If I stop there, it's got 10 in front of it. It's a 2-digit number. I've got to stop there so it has a 1 in front of it.
Okay.
You move it until you have a single digit between 1 and 9 in front of it. Right, so up here, I can't stop there. That's 3 digits. I got to stop there so I have a single digit in front of it.
And you count the single digit in the exponent?
You count the number of times you moved it.
Till, yeah.
Straight up.
So, yeah.
So I had to move it 1, 2, 3, 4, 5, 6, 7 times. So that's why 7 is negative because it was small. Or if you like, because you had to move it to the right.
Yeah.
Whatever makes more sense.
I like that.
So of course you can have problems going the other way, right? You'll have a problem like this. 5.72 times 10 to the negative 6. What would that be as a straight up decimal number? Here's the shortcut on negative powers. How many times do you have to move the decimal? Don't you have to move it once to get around that stupid 5? And then the rest of the motions are going to give you what?
0.
0. So you always have one less 0 than this number. Once to get around this number, and the rest are zeros. So how many zeros do I have here? 5. That's awesome. So if it was negative 28, I just put 27 freaking zeros in front. So beautiful shortcuts. You don't have to sit there. 27, 28. Okay. Right? Okay. If that would have been a positive, I would have just moved the decimal that way 6 times. 1, 2, 4 zeros. Do you see there's a shortcut that way too? You just got to be careful. There's normally more numbers here. So 1, 2, the rest are zeros. So there'll be 4 zeros. If it was a positive 6, you with me? So this section should be sort of a breath of fresh air, actually. It should be pretty straightforward. Scientific notation. That's plain. So next time we'll get into polynomials.
I don't know what that is.
Oh yeah.
I forgot to turn them on. No, I didn't. Good.